section 28 is putting this all together. So it's just a summary of curve sketching. So not only are we going to do the first derivative and second derivative for increasing, decreasing, concave up, concave down, but we're going to find x-intercepts, domain, and range. We did a lot of this on the homework the other day, right? So we're going to put everything together, horizontal asymptotes, vertical asymptotes. So the very first one, so it says sketch graphs of the following functions, and I have different steps. So I have you find the domain, the vertical asymptotes, horizontals, and so on. So we're going to start out with one that doesn't have any asymptotes. So it says sketch the graph of the following function. We have 4x cubed plus 18x squared plus 24x plus 8. So what is the domain for this one? Yeah, it's everything, right? We don't have any square roots or denominators or anything, so our domain is negative infinity to infinity. All right, there is no vertical asymptote. We know there's vertical asymptotes when we have denominators, right? No denominator, so none. And then I ask lots of other questions. So I say, well, what about the first derivative? Let me write my original here. So my original was 4x cubed plus 18x squared plus 24x plus 8. So my first derivative is going to be 12x squared plus 36x plus 24. And we're going to do all of the steps that we usually do for first derivative. So we're going to find our critical values by setting it equal to 0. I'm going to pull out the GCF of 12. And I'm going to factor. So I factor into 12 times x plus 2 times x plus 1. So I get critical values of negative 2 and negative 1. So since we're talking about the first derivative, these could be maximums or minimums, or it could be like the x cubed point where it's neither a maximum or a minimum. So I put them on a number line. Now, a lot of these steps, you are going to be smart enough to kind of skip through, okay? So we know the original function is 4x cubed. In an x cubed graph, the parent function looks like this, but most x cubes that we talk about go up and down, right? So if it was just kind of tapering off and flattening out and then going back up, there's only one critical value. This one has two critical values. So it's definitely going to be something like that. Do we see that? You get it? So if I'm testing in my y prime, I can plug in negative 3 and plug it in right here and say, oh, I have a positive times a negative, so that's positive, right? Or you can just be smarter than the system and say, oh, it's an x cubed graph. This better go up, down, and then up, right? If it doesn't, we've done something wrong. So that means that we're going to have a maximum at negative 2 and a minimum at negative 1. So let's find the y values that go with those. So f of negative 2, if I go back to the original and I plug in negative 2, kind of use your calculator like an I-step calculator, I guess. I should have found these values for you much faster. Anybody have it? A lot of times I plug it in for y1. Oh, yay, I do have it in for y1 still. That was lucky. All right, so when I plug in negative 2, I get 0. And when I plug in negative 1, I get negative 2. All right, now we do the second derivative step. So our second derivative, I'm going to take the derivative using the polynomial version. I don't want to use the part that was already factored, right? That's too much. So when I take the second derivative, I end up getting 24x plus 36. So when I set it equal to get our points of interest, I get negative 36 divided by 24, which is negative 3 over 2, or negative 1.5. So based on your knowledge of what this graph probably looks like, what do we think our concavity is? Is it up and then down, or down and then up? Down and then up, because remember, it's probably like this, right? So negative and positive. So you can kind of skip through some of these steps. But we do know that there's a point of inflection at our negative 3 over 2. All right, horizontal asymptote, none. Intercepts. So if I'm finding an x-intercept, I plug in, right. It's not a rational function. Rational functions are fractions. All right, so to get an x-intercept, I plug in 0 for y. So when I plug in 0 for y, this is a tricky one. I have 4x cubed plus 18x squared plus 24x plus 8. The AP test would never put one like this that would not be a calculator one. But I think that I trust that you guys can do this without a calculator. Totally. You're on it. You got this. What are our possibilities for rational zeros? In other words, use P over Q, my favorite theorem from Algebra 2. Use the P over Q to find it. So our possibilities for P over Q would be plus or minus 1, 2, 4, and 8, and plus or minus 1 and 2. I know that I can eliminate half those possibilities. I know my number is not going to be positive. Do you guys all see that if I plug in like positive 1, positive 2, positive 4, it's not going to be 0. It doesn't work. What do you guys want to try? Negative 1. Negative 1 doesn't work. I already did it. Negative 2. Let's try it. So we get 4, and we could also pull out a 2, right? That would make it less choices. But if I have 4 and then 18, 24, and 8, and I drop the 4, I have negative 8, 10, negative 20, 4, and negative 8. Oh, look. Can you believe that? It works. Good thing I already did this in fifth period yesterday.
1, 2, 4, and 8.
Remember the factors of 8? And the factors of...
You should do the very last term.
The last term is the P, and then the first term is the Q. All right, you don't need to know it for AP Calc. It's fine. Yeah. What did I do? A 4 what? I think I did too. A factor. Oh, 1, 2. Oh, okay, that's fine. I was already skipping ahead. All right, so here we go. So when I factor, I have x minus 2, 4x squared plus 10x plus 4. You're saying that AD needs a point?
Yeah.
Was it AD that got it? Or was Olivia going?
No, I didn't go for it. Did you go for it? Okay.
All right, it is x plus 2. Now you're really messing me up, man. All right, Sydney, was that you? All right. All right, so now I'm going to pull out a 2 out front. So I have x plus 2, and then I have 2x squared plus 5x plus 2, which factors into 2x and x, 2 and 1, both plus. So what are our x-intercepts? What points? We have negative 2 comma 0. We have negative 2 comma 0 twice. It has multiplicity, 2. And then we have negative 1/2 comma 0. That's a negative 1/2. It's kind of sloppy. All right, so on your homework, if you guys have one like that, you don't have to use P over Q. You can use your calculator to find the 0. You would just do like your second trace, 0, left bound, right bound. Right, remember that?
Do we need to do the intercept?
Yes. I asked for all of this. All right, y-intercept. We plug in 0 for x. That's the easy one. Yep. So 0 comma 8. The whole point of this section is that we should be able to do everything without a calculator, right? And we can. So far, we've done it without a calculator. Yeah, Carolyn?
What does multiplicity?
Do you guys remember multiplicity? So that means that at negative 2, it's going to like bounce and hit it and then bounce back down, which we'll see anyway with our second derivative and first derivative because it was a maximum. All right, so if we put all this together, we're going to start with our first derivative points. We said at negative 2 comma 0, we had a maximum. So I'm going to draw that point, and I'm going to do like a little like bump there so I know that it's a maximum. And then at negative 1 comma negative 2, we have a minimum. So I'm going to do a little bump there. And then we have something in between that, so a point of inflection. So I haven't found where that point is. So if I found f of negative 1.5, or negative 3 over 2, I get negative 1. So that point of inflection is going to be at negative 1.5 comma negative 1, right there. Does it make sense that it would be there? Yeah. So we're kind of connected.
So you plug in that to the original? Or no, you plug in
into the original, yeah, because you're finding the point. Yeah, go back up.
You
I plugged it into this f of x original. To find a point, every time you find a point on a graph, you're using the original, right?
So with points of inflection, can you just take the x coordinates of...
Not always. Yeah.
I figured it was.
It's not always directly between.
I'm gonna do it.
All right, how about the X-intercepts and Y-intercepts? So X-intercept, we said it's crossing at -2, so we got that one. And the reason that we have multiplicity is that it bounces, right? We talked about that a long time ago, Algebra 2. And then we also have at -1/2, so right there. So it's going to turn pretty quickly. So at -1/2, it's going to cross. And then it crosses along the y-axis at 8. Okay, so it's right there. So our graph should look something like that. And I would look for labels on all. So there's a max here. There's a point of inflection. Because you only have 2 questions for your homework. So you should do them perfectly.
Wait, was that the thing you gave us yesterday?
Probably. I won't worry about the X-intercept, Y-intercept, that's fine. So max, min, points of inflections I want to see. Yeah. I'll pass it out, it's fine. I gave it to those people that were still in here so they could start if they wanted to. All right, so the next one's number 2. So same idea. So we're going to go through all these steps, but this one's different. How is this one different? It's a rational function, right? Rational functions have denominators. We're going to have vertical asymptotes, okay? Vertical, horizontal. All right, so our domain is going to be -infinity to infinity. No, what can I not have? 0. So -infinity to 0, 0 to infinity. Vertical asymptote is at x equals 0. Set your denominator equal to 0. All right, first derivative. In order to find the first derivative, I tend to try to make things as easy as possible. So I think of this as x squared over x cubed, which is 1 over x, minus 3 over x cubed. So I would often rewrite this as x to the -1 minus 3x to the -3 before I even start. It's just easier to take derivatives, right? So our first derivative, f prime, is going to be -1 x to the -2 plus 9 x to the -4. But once you take the derivative, you should really get common denominators. So we can find those critical values. So I'm going to rewrite it as -1 over x squared plus 9 over x to the 4th. And I'm going to multiply, so I have x squared and x squared.
Why do you have to find the?
Wait, x to the 4th, x to the 3rd.
I'm going to multiply by x squared and x squared on top and bottom.
Oh, because you put them on the.
And then I'm going to get my common denominators, right? So I'm going to get -x squared plus 9 all over x to the 4th, which factors. So it's the same as 9 minus x squared. Do you guys see that? How does 9 minus x squared factor? 3 plus x, 3 minus x, yep. Okay, so we get critical values of -3, 3, and then it's undefined at 0, right? So -3, 0, 3. And we had a vertical asymptote at 0, so I usually draw like a little dotted line. So I know, okay, that's not going to be a max or min. There's something happening there. It's an asymptote. And then I'm going to test each location. Unlike the polynomial one, you probably don't know what this one looks like, right? So we're going to actually plug in to the first derivative. And I always plug into the factored form if possible. So I'm going to plug in -4, and I get negative, positive always on the bottom. Do you guys see that? X to the 4th. Okay, so I get negative times positive is negative. And then I'm going to try -2. I get positive, positive, so plus. If I try 2, positive, positive, so plus. If I try 4, positive, negative, so negative. So we go down and then up, and then we go up and then down. So what's happening at -3 and 3? -3 is a
Points of inflection. Or
no,
no,
point of inflection.
maximum.
A minimum. 3 is a maximum, right? That's called the first derivative test. If something goes down and then up, it's a minimum. If it goes up and then down, it's a maximum. All right, as long as it's the slope is as long as you don't have an asymptote or something there. All right, so we can find those values. You can go back to the original, hey, and find f of -3 and f of 3. Did anybody do that? What is my original? So x squared minus 3 over x cubed. So when I plug in 3, I get 9 minus 3 is 6 over 27. 6 over 27 is 2 over 9. Is that right? So 2 over 9. And then the other one ends up being negative 2 over 9. So the negative 3 was a min, 3 was a max. All right, so second derivative. I don't want to go from this quotient, right, the one that I was plugging in for. I don't want to go from there. I want to go from the polynomial form with negative exponents, actually. So I'm going to have f double prime of x equals, so if I go from here, I'm going to have positive 2 x to the negative 3 minus 36 x to the negative 5. So I get 2 over x cubed minus 36 over x to the 5th. So I'm going to multiply by x squared and x squared. So I get 2x squared minus 36 all over x to the 5th. So if I set my numerator and denominator equal to 0, I get points of interest. So 36 is equal to 2x squared. I get the square root of 18. So what's square root of 18? How do I write that? I was just doing this in algebra 2 today. 3 root 2. You guys remember this? Yes. All right, so if